Jonny. I just get so happy that you're here to do the intros and they go well. I survived without you, but it was awful and I don't recommend it.
It's a timing thing. I've got it all figured out. Like I've got a little clock over here, you know.
Yeah, no, it's, you've engineered it into perfection. Thank you for that. Hello, GitOpsians. Welcome. I don't have any announcements this week, so very short intro. Joining us today is Uther and Gerald, and I don't introduce people, so I'm gonna let them introduce themselves, and then we're gonna. I guess the topic is. I don't know. I had a whole email thread discussing it, and I say I guess. The topic of conversation today is Red Hat and what and how we do and enable DevOps, right? So take it away. I didn't ask you which of you was going first, so you can choose now.
Well, alphabetical or something. In which case, it's Gerald.
Oh, I was going to say rock, paper, scissors.
Yes. All right, Gerald, go.
So my name is Gerald Nunn. I am the GitOps Technical Marketing Manager at Red Hat. So I help our customers as well as our internal field people, consultants, solution architects get the most out of our GitOps product, which is OpenShift GitOps and is based on upstream Argo CD. And I'm sure everybody who's listening to this call probably is very familiar with our GitOps. Hopefully it's very familiar with our GitOps offering. So that's me. Ian, did you want to introduce yourself? Or?
Yeah, sure. Hi, everybody. Name's Ian Lawson. I don't know what I do at Red Hat anymore. I'm a developer advocate, global developer advocate. For 12 years, I was a domain solution architect, focusing on deep dive technical discussions with customers, both happy and angry. Prior to Red Hat, I used to work for a living. I was a developer with the UK government space for 25 years. So I'm kind of enjoying my retirement from being an actual developer, playing in the vendor space. The one thing I always say to people about Red Hat is that I wish Red Hat was around 20, 25 years ago when I was writing software, because the stuff we're kicking out today is the stuff I needed then. So I always get very upset at the end of meetings and ask people if they'd like to employ me so I could use our tools. But anyway, I just talk about all of our products at great length until I'm told to shut up.
I call that I call what we do on this show a lot. Just the armchair coding, right? So I know how all of this stuff works, and now I understand your business case. So roughly, this is what you're going to do, right? Armchair coding.
Yeah, and also it's incredibly fun from my perspective because I don't have to deliver anything. Having 25 years of actually having to physically deliver software that did something correctly, it's nice to be able to just not have to deliver things at the end of the day.
Well, you delivered software that did it correctly?
Well, put it this way, I no longer write it, so I assume not.
That's fair. Yeah, no, it's I honestly what was it like? I was talking about this at KubeCon Valencia, right? When it was still GitOps Con was the co-located event as opposed to ArgoCon. And the things that we had to do that modern GitOps just does for us is I actually asked the audience, it's like, okay, so who here has who here has pushed code to production with FTP, right? And 5 or 6 hands went up, including mine. And people were I was like, okay, so there's a few of us. And so then I later asked, I was like, okay, so who here by show of hands has daisy chained Jenkins jobs together, right? The same hands went up. And I looked at the crowd and I was like, okay, so all y'all are making me feel pretty old, and you actually can leave. But the things that we did to do what is just now done almost automagically for us by these tools that have been developed. I feel you on that, on the, can I go back in time, but have this thing, and how much better my life would have been at what else could I have accomplished if I hadn't spent all that time doing it the hard way?
Yeah. Yeah, I said, when I talk to customers about this, I always talk about what we used to say was a 70-30 split. And as a developer, you used to spend 70% of your time not writing code.
Yeah.
all the kind of frameworks, the boilerplate, understanding the tool set, and you just use 30% of your time to actually write the physical code. And it was ridiculous. And I was talking to a customer about 3 months ago about it, and I was saying, in the old days it was 70-30, and this customer said, well, nowadays it's 80-20. It's actually got worse because of the complexity of software, because of the complexity of tools and frameworks and all these other things. And in some ways, I really envy developers today because you've got access to these huge amount of tools, good stuff with the Red Hat kit, with the OpenShift things. But you've also got this huge weight of additional frameworks and languages and multiple ways to do things. And we're going to talk later about Red Hat Developer Hub, which is designed to remove that cognitive load overload that developers get nowadays and let them actually do the work. But, it was never perfect for us. When I used to deliver software, I used to, my sort of code context was a Post-it. I'd write the software and then I'd write the environment variables on a Post-it and give that to the ops guy and then walk away and let him sit there and cry for a bit. And ops used to absolutely hate me. So all this kind of thing with DevOps and DevSecOps and the combination and the breaking down of the barriers between the developer and the person who runs it, business as usual, it's absolutely fantastic. And I say we've just been working on something, Gerald and myself, a demo based on composite products. And I just constantly amazed at how cool it is nowadays, how the control mechanisms are there, how the compliance is done through the GitOps side. It just gets rid of that concept of drift, the old concept of drift, that ops were always coming to you and saying, we need to patch this. And it's like, well, that environment variable is meant to be this. 3 months ago, and now it's 15 other environment variables. Where did they come from?
Yeah. I had one time, exactly that, right? Found out the very hard way that staging in production did not match. The VMs did not have the same amount of memory. And the new feature that I just spent all that time testing and we just released was incredibly memory intensive. So, Of course, what happened the first time somebody tries to use it in production, right? It falls over. And I'm getting yelled at. Right, I was the lead quality engineer for this. I'm literally getting yelled at. Which, don't yell at your quality engineers, guys. Like, what the heck? Stop that. And I look at the CTO and I say to him, I told you that testing and staging did not guarantee production behavior. I raised this risk to you because they didn't want to feature flag it or do anything like that to try and do a soft rollout. Like, that was not that. They didn't want to do that, right? So I said testing and and like this is exactly what GitOps solves. Like this doesn't happen in GitOps environments, right? And he just like is stunned for a moment. And bless him, the lead engineer who sat at the desk next to mine looks at him and goes, "She did tell you that right in front of me." And like that was the end, right? The guy just was like fine and like quietly like walked away after that, right? Please note I didn't yell back, kept my cool. And so for the folks that, I think everybody here probably knows this, but when you needed to increase memory on a VM in those days, you had to restart your VM.
It used to be a world of pain.
Mm-hmm.
So I come from a Java background because I was there when Java kicked off, when it was called after a tree. And I'd spent so many times on projects where they would just up the heap space and stack space. When things ran out of memory, it would just raise the XMS until you didn't get garbage collection anymore, so you didn't have any problems. And that seems to be the standard response. And of course, when you're absolutely dead on, when you actually do these testing, you can't do functional testing on a test system. And there were various places I worked for that allowed us to do functional testing on the production systems, which was insane. But all of these kind of complexities, they shouldn't be of interest to the developer. 100%.
Right? Yeah, no.
You write your code, you deliver your code. And in the old days, we called it throwing over the wall. You'd write your code and you just stick it on a disk or whatever you did, give it to the ops person and say, it's your problem now. And then they'd phone you at 2:30 in the morning and say there was a stack trace. Normally.
It was always some dumb time like that too. There's one of the DEs here at Red Hat has this great story about a Java system he worked on where they just had a cron job that restarted it every 19 seconds. Otherwise it would fall over because I guess the heap would overflow or whatever. I've never done any actual like serious Java development, so I've never had to get into heap man and garbage collection. Like a little bit, I've had to SRE some of those things, so I've seen it, but it's like, all right, I can see that this is like a whole problem and I gotta go kick this thing over versus really like deeply understanding it. Completely different, totally different things. But yeah, basically it was the garbage collection didn't do the things, the memory got completely overloaded, and so they, until it got fixed, they just had a cron job that kicked the thing over every 19 seconds. That's the time interval on that for me, truly. That just makes me giggle.
Precision.
Number. Why not 20?
Yeah, 19, not 20, not 25, not 15, 19. That is... Anyway, I wish I had queried him. Like, it was something he said in passing, and we had a very busy meeting, so I didn't get to dig into that. But like, if Jesse, if you're watching, please explain to me the testing that went into identifying 19 is the correct number. I would like to know. Well, anyway, since we've done this a little bit of nostalgia, shall we go dive into the modern era? What we got?
Yeah, I'd say, how do you want to play this? Because I say Gerald is the man about the GitOps side. I tend to just nick his stuff when I want to demo it. And I talk about Red Hat Developer Hub and OpenShift and how OpenShift is God's gift to developers and things like that. Do we want to just step through, perhaps explain what GitOps actually physically is compared to DevOps?
I think that's a great idea, because there was actually a comment on one of our recent videos where someone was like, hey, I'm really new to this space and I didn't understand what was happening here. Like, is there a primer somewhere? And I was like, oh, we're overdue. So that would be absolutely perfect. And I hope the viewer who watched that recording later finds, I'll actually go respond to their comment and link this whole thing for them, is what I will do. Because I think that we're overdue for a review.
Yeah. So Gerald, do you want to go at having a basic?
Sure, I could show some slides, but I think it's more fun to just have a discussion about it and get everybody's thoughts and opinions. So from my perspective, GitOps is really just taking the developer workflow and applying it to infrastructure, in the sense that Git or potentially something else can be your source of truth. And you have a GitOps engine that essentially takes that source of truth and makes sure that the target, the destination, is consistent with that source of truth, right? So if it deviates in Git, i.e. somebody does a new commit, the engine makes sure that that deviation or that new commit shows up in the target destination. If somebody changes the target, which deviates from the source of truth, the GitOps engine can then reconcile that back to the source of truth, or optionally just flag it as something for a user to look at. And from my perspective, the real benefit of GitOps over, say, a traditional automation tool like Ansible or Terraforms or whatever else is out there is that reconciliation loop. The fact that it's two-way and it's not one way. Like where Ansible, you run a playbook, it will update a bunch of stuff. It's great. But Ansible has no knowledge if somebody goes and changes it after the fact, right? So that's really, from my perspective, where GitOps comes into play. It really leverages the declarative nature of Kubernetes. Talked about the good old days and Kubernetes, and the way that you just can say, hey, here's my application I want to deploy with CPU, memory, here's my image. You figure out where it goes on your hardware. I don't care. Makes things so much easier. And it's really why I think GitOps works really well in a Kubernetes-based environment. And achieving that same capability in a more traditional infrastructure tends to be more complicated. And that's why you see folks like Upbound with Crossplane and other systems that are essentially leveraging the Kubernetes declarative API to try to put that declarative layer on traditional infrastructure. So that's a fairly long-winded, somewhat deviated talk about GitOps, but from my perspective, that's really why GitOps is a thing. From a DevOps perspective, I really look at DevOps as a methodology and GitOps as a key component of implementing DevOps in a way that works in the real world.
Yeah, that sounds cool. I'll add something very, very quickly to that, because coming from a development background, I love OpenShift and I love Kubernetes, and I often get told to stop talking about it, especially after work. But Kubernetes and OpenShift are both what we call desired state engines. When you interact with OpenShift, when you interact with Kubernetes, you just go into it and you say, I want this. I want this object in this state, or I want this object to go away. And the beautiful thing about OpenShift and Kubernetes is that everything, every single aspect of the engine and the applications are all objects, and they can be defined as code. You get a piece of YAML, as Gerald said, it's declarative. So rather than having an endpoint for each type of thing you can create, you have a single endpoint where you throw a piece of YAML, and the first piece of YAML, the first thing in the YAML says, I want an object, I want an orange, I want a banana. You then have what we call the etcd, which is the brain, which stores the desired state of that object. And then we task the worker nodes with a tiny little robot on them called a kubelet to physically realize those objects. And the nice thing about the two-way mechanism that Gerald was talking about is that the user just says, I want this. And OpenShift says, I'm on it. And then when it's passed down to the actual worker node and realized, the actual kubelet on the worker node says it's fine, at which point it's reconciled. Any point in the future, let's say if the orange falls off the shelf or gets peeled and you need a new one, the kubelet will say the object is no longer healthy, the orange is no longer healthy, and OpenShift will put it somewhere else until it becomes healthy. Now, the combination of that reconciliation loop and the fact you can declare everything as code is what makes GitOps so powerful, because you store those tiny pieces of declarative YAML that tell you this is the state I want. And then the Argo CD engine actually pushes that to a cluster and sits there 24/7 as a watchman and watches the two. It watches the actual state and the desired state. And if they fall out of alignment, it resynchronizes it. And that's the beauty of it. And when I'm talking to customers about this, I always push the fact that it's abstracted. You know, when you're talking about the GitOps stuff, you don't care what the objects are. They're all just declarative definitions. And that's a lovely, simple approach. As you step down into the objects themselves, you get more complicated, get down to the pods, get down to using Tecton for pipelines and things like that. But it's a nice, simple way of doing things. And we like simple things. And we also like things that are automated. And I want to bash this question over to Gerald very quickly, because I've been talking to a number of customers. And when you're using OpenShift, this isn't just applications. You can define the cluster state. You can define the state of the users, the network policies, because everything is declarative. So I've got some end customers that are using GitOps to define their cluster states and also to define, for example, pipelines. So you define the pipeline in Tecton, which is an object itself. You put that pipeline for, let's say, creating a user, which creates, you know, a project, user, network policy, and all those things. And you can use Argo CD quite cleverly to actually keep a cluster in configuration. And this is one of the things I was thinking about. I'm interested in Gerald's opinion on that, because we tend to focus on Argo CD and GitOps from a pure application perspective within Red Hat. And I've always thought, it'd be more exciting to just do the whole thing.
Yeah, I mean, you pretty much hit the nail on the head. From my perspective, GitOps is for everyone. I used to have a slide that had the ops on one side and the developer on the other side, and it benefits everybody. Absolutely, you should be maintaining your cluster state using a GitOps methodology. So store all the manifests for the different operators you want deployed, the different configurations that are in OpenShift. OpenShift is somewhat unique in the Kubernetes space in the sense that the cluster is managed by operators and manifests, more so than a traditional Kubernetes environment. So it really lends itself well to a GitOps methodology and approach in terms of managing the cluster configuration in that state. And to Hillary's point about, staging and production not being the same configuration, that's really where GitOps shines from a cluster configuration, is ensuring that your multi-cluster environments are essentially configured and set up the same way across them. And you have that agent, as you mentioned, that is constantly monitoring it and will let you know that they're out of sync or out of state. So you avoid the whole configuration drift scenario that was the bane of my existence as a developer, where I would deploy something in dev or staging and it would work, and then not in prod, and try to figure out why it's not working in prod is almost impossible. So it's really good for that. And really, there's two personas that go with that. The platform team that manages OpenShift are the ones that essentially manage the cluster configuration aspects. And then the developers are the ones that manage the applications, or the application support teams, right? It's typically the two personas that you see in that. How they work together is going to vary depending on your organization. So if you're a fully matrix DevOps organization, you'd probably be working quite a bit differently than somebody that's more in a traditional enterprise silo organization, right? Where the ops and dev teams are siloed. And as you mentioned earlier, you throw things over the wall to ops and have them kind of deploy things, right? But yeah, it works great. I have all my clusters configured that way. I could go off on a tangent and start demoing all that stuff, but yeah, just second you and thumbs up. Absolutely.
Yeah, I would add to that as well, though. There's a couple other aspects that I've certainly seen, and it's fun that we're talking about this because either you actually talked about this in like last couple episodes. I've been writing a book on platform engineering with a couple colleagues, and I actually talk about GitOps for these things in the book a bit. Not at like great length because there's a lot of things we're talking about, and there's other pre-existing artwork over all this, right? But one of the things that I think is somewhat of missed is like GitOps is also a great way to enforce security. So like you were talking about RBAC and everything else like that, right? So if you've got a declarative way of, having users are managed, and like that is the way that users are managed. This is the only entry point for users, and their permissions, and anything else gets undone, right? That's a really good way of managing security posture. If somebody's permissions needs to change, right? That change in their permissions, that's a pull request, right? You've got a whole trail of the change from like inception and reasoning all the way through. The other thing is that if you have, right, everything declarative, and this really works more so for production, not so much in dev clusters where who the heck knows, because you realistically, if you've got a cluster being used by developers, they're going to have like way higher levels of permissions over there than they're going to have in staging or production, assuming they even have access to production. They probably don't. They probably have access to wherever the logs off production are being shipped, but they should not have access to production. Don't just give people access to production. Anyway, so the if the only thing that can land on the cluster is whatever is in Git, then when a security thing happens, you know exactly your surface area for risk. Like you know it very, very, very quickly because everything is declared in an easily scanned and reviewed location to understand. Like this is how you're able to easily get an SBOM, like all these other things, right? So you know if you're impacted by a CVE, you know if you're impacted by a log4j, right? Very, very quickly. And actually for us in the SRE organization, because of our use of GitOps, when log4j landed, we knew immediately what our surface area was, like how at risk any of our stuff was. And then, Red Hat has our whole, secure supply chain things, and we had a lot of other stuff going on. So like that kind of was even the teams that didn't use full GitOps, it was still like very much understood because of that leverage. Even if there wasn't a full reconcile, that source control as truth was very much true. So the security, the way it can really augment your security game in GitOps is something that is, I think, sometimes a bit undersold. And I think it's because there's also kind of the caveats of, but it depends, but also this and so on. Because if somebody has cluster admin, they can technically bypass your GitOps system. But that's why you just don't give people cluster admin. You just don't do that.
Well, yeah, the thing is, if they have cluster admin, even if they bypass your GitOps system, if it's something that Argo is managing, you know about the change.
Yeah. Mm-hmm. Yeah, you definitely do. You definitely do. And you can set up monitoring and alerting and all kinds of other things to catch that. And, you policies. Yeah. You can do so many things. But yeah, so that's just kind of the other thing is we talk about it for delivery a lot. We talk about it for management a lot. It does do the security things. It can't be the whole security story. It can't. But it does the things.
Yeah, it's an important piece of the puzzle.
Yeah, one thing too, and depending on how you like create your values and set your values and stuff like that up, like if you're using Helm, if you're a Helm person, unlike Gerald,
I like Helm.
I like Helm if I don't have to manage it.
No, I know. I know that like Gerald and Christian were big customized people. So but depending on how you set it up, I mean, you can go look at your applications, right? And you've actually got that bill of materials that's on your cluster, right? So you have an inventory of everything that you're deploying out there. And then, we talk a lot on the infrastructure side about, pets versus cattle when we're talking about cluster deployments and stuff like that. And this really lends itself to that because now it's like, all right, if I have to blow this cluster away for whatever reason, right? Maybe I don't need it anymore. I need to resize it and I don't want to, do whatever it is. You can just redeploy your cluster, apply your GitOps config to it, and then all your apps are redeployed and stuff like that. So I think like just the overall, and Ian, the one word that I like to say a lot when we talk about this stuff is evolution, right? Because like 100 years ago when I was growing up and I was doing this, like you had to do everything by hand or through a freaking shell script, or if you hated your life, you could do it in Perl. But like,
shots fired, Johnny. Dang.
There are worse languages.
If you're a Perl person, which I know Hilliary is, I'm just that's alpha nerd level stuff. Like that's big time stuff. So, but no, it's but it's that evolution, right? So back in the day, you had scripts or you had to do it by hand, and there's you're prone to mistakes, and like even that Perl script, no matter how great it was, like there's a potential there that something could be passed to it incorrectly, and then disaster. And I think that like now as we get better and better and better, and the tools are getting sharper and sharper, like we're able to apply like legitimate precision to our deployments, and I think that that's incredible to be where we're at now, and then we're not even done.
Yeah. That's an interesting philosophical question there as well, because what I'm seeing a lot of is, especially with the customers I deal with in the field, people have evolved. They've come through this process of having to write their own systems, write their own control mechanisms, things like this. And you get to the point where you go in and you say, this is an incredibly easy way of doing it. You go down the Kubernetes route, you pick a good Kubernetes, i.e. OpenShift, because every other version of Kubernetes is terrible. And you put GitOps there and you use the security protocols and all those kind of things. But you've got lots of people who've got existing knowledge of the systems that they've used. And it's a comfort factor, and they know what they're doing. They know, it's an intricate set of shell scripts or whatever to actually do a deployment. And it's quite a big task to get them to understand the basics of how this works so they're confident with it. It's one of the worst problems I've had with dealing with people when I've been trying to actually push, because I'm not a salesperson. Even though I worked in a sales organization for 12 years, I'm not a salesperson, and I always never go on with salespeople. And when I'm talking to customers about these kind of things, I just want them to understand how simple it is and how basic it is. And we have a bit of a learning curve issue with Kubernetes and OpenShift, and I don't think we should have. Under the covers, it's incredibly complicated. On the surface, if you look at what it actually does, it's incredibly simple. But it's a big push to try and get people to understand the strength of this solution. When you do, it's like the light goes on and everything just gets thrown away, and they just use GitOps and to their heart's content. And what I'd like to see at some point is a way that it makes it much easier for us to actually show people how cool this is and how easy it is and how reliable it is. So you can put to bed all the kind of worries they've had from years and years of developing their own integrated systems, their own sort of approaches. And not every single person you talk to in the world, unless they were born yesterday, has a previous version of something that's similar to GitOps. And every organization is different. And there has to be this nice message. And it's not a sales pitch. It's that this is just bloody brilliant. And it's really sweet, and it's easy, and it's solid, and it's elegant. I always get told to leave the room when I start talking about how elegant Kubernetes is, but it's a wonderfully elegant system under the covers. And again, I'll stop the philosophy and start talking tech now.
Yeah, well, I was gonna say to Johnny's earlier point, Johnny, the one-click disaster recovery. That is like, okay, cool. I need to basically, target a new region because, East US is down, or whatever region it is in whatever cloud you use. And, I'm going to target, I don't know, where else do they have data centers? I know the Azure
West
ones.
2 or even
West
EU,
West Germany, something like that, right? I'm going to go over there. I'm going to put in a little PR that says this is where we target now, and I'm going to run that, and then boom, it just does the things, right? The amount of, that's your level of work for a disaster recovery when you have implemented GitOps. And I think this will go well nicely because we're actually going to talk to the OC Mirror team in 2 weeks about their tool and kind of past version and current version. And it does allow for some of that as well. And I've also seen that you can use it to kind of mirror things across like air-gapped environments, and air-gapped is a whole other problem. But anyway, but yeah, that disaster recovery being that simple. I mean, I remember one of the, land of VMs, and you spent 4 hours practicing your disaster recovery because that's how long a disaster recovery took. And that was like, okay, cool, we can do it in 4 hours, we're good, right? Now I can do it in, how long does it take a cluster to build?
Yeah.
An hour?
There are
Yeah,
two components, though, to
pretty good.
disaster recovery with an OpenShift environment. One is the resources in OpenShift, so that GitOps essentially obviates the need largely to backup etc. D, right? Essentially, because everything's in Git anyways. Why do I need to back up etc. D? The one thing it doesn't take care of, though, is state. So if you're using PVs, you still need to back those up and have a mechanism for doing that. But that can also be incorporated as you're getting at Hilliary into your GitOps disaster recovery process and save a ton of effort when you only have to deal with that one very little thing that's separate from a GitOps environment.
Yeah, it really starts.
Sorry. I'd add something to that as well, because I've been talking to lots of people about disaster recovery in the last couple of weeks, because people are very concerned about things like VMware and other things of that consequence. But we've got a fantastic solution based on Metro. What Metro does is it takes a physical synchronous copy of the underlying storage that you're using on your cluster. So your PVs are automatically synchronized in near real time to another physical location. And I always had another philosophical question here. I always had a lot of problem talking about DR with Kubernetes and OpenShift, because as far as I'm concerned, ignoring kind of physical state and things like that, you don't need DR with an OpenShift cluster. OpenShift is self-healing. You have additional worker nodes, lose a worker node, things get moved on to another worker node. It's the whole policy behind Kubernetes and OpenShift. But again, you have a lot of customers who are in the old school way of doing hot, near hot, or hot DR, and you can do that because we haven't talked about ACM. ACM is our supercontroller, which sits above OpenShift clusters and acts as a supercontroller for placement of workloads. And a combination of that, because correct me if I'm wrong on this, Gerald, we've actually integrated Argo CD via application sets into the back end of ACM now, rather than using the old school ACM way of doing the application.
It is there. The old school way is still there as well.
Yeah,
it does support application sets and some features around application sets to make them easier.
Yeah. So that you have this kind of super control and disaster recovery across multiple clusters, and it all comes from the simplicity of the object model and the fact that everything's declarative. And this is where GitOps is a godsend.
That combination of ACM and GitOps too, right? It's dope in OpenShift because you can say you can use placement policies and stuff like that, and really tune down to okay, the resource, how you want to deploy an object to a cluster and stuff like that. If you want to spin up a new cluster and do some stuff, you can do it that way. It's super dope when you have them all working together.
Yeah. I'll say that what I've been talking to people a lot about is node placement as well. That's another beautiful feature, because you can tell, because I've been talking a lot about virtualization. You can say which machine you want to push a VM on. You can say which machines aren't allowed to have developer mode. That's the other big thing I wanted to mention as well, is that in the old days, we had distinct clusters for different forms of behavior within the organization. You'd have a development cluster where your developers were kept behind bars. You'd have a test cluster which the testers use. You'd have pre-prod. You'd have non-functional, functional clusters. I've been pushing, and people are going to grimace at this point, but I've been pushing to the people I talk to just have a single massive OpenShift cluster and use node placement.
Oh.
I know that would annoy somebody.
Oh no! We're gonna fight.
Node placement
and
also the node capabilities to express the actual physical components of the nodes.
Nope.
So you can actually control the placement of the workloads.
Nope.
Go on, tell me why I've been lying to customers for the last 2 years.
Okay, here's the thing. It's not that it can't be done. It's that you have to be so careful, right? You have to be so careful. And that gets down to making sure that people only have access to their namespaces, and those namespaces can only be on certain nodes. And so all of the affinity and anti-affinity and node selectors and labels and all of that pieces. But here's the other thing. God, there's a lot. Okay, shared resources. All right, let's just go down the steps. Starting off, you've got one cluster, you've got one set of networking. You got something that's doing bad things, it can overload the entire cluster networking layer, right? It's hard to do, but it's a risk, right? So you've introduced a risk there. Let's go down one. Your control plane. Your control plane is finite in size. And even if you increase your VM size, your actual etcd capacity does not increase. You actually have to rebuild a cluster to get that. I think they're introducing that capability up in one of the upcoming versions of OpenShift. I don't remember which one, and don't quote me anyway, because I don't know if it's actually even going to make it. So whatever. It's a feature that's coming, but it's not there today. The number of times I have seen etcd get over full because people do not understand what you have to do to ensure etcd doesn't get over full, you would not believe. And so that's a really big problem. You have all of those environments, all of them working. You put your load, your stress test, you put your normal testing, you put your production, you put your dev stuff, all of those objects that are being created and stored in etcd, unless everybody is very precisely adding a correct time to live, congratulations, your cluster's falling over. I literally saw it like 2 weeks ago. It is very common that this happens. Would not recommend this at all. Unless you understand at every single layer how those how that isolation can fail, do not do this. It is dangerous. Next, CPU. So every node is essentially a virtual machine, right? And so it uses the Kubernetes uses the completely fair scheduler, which is like the same as Linux kernel, right? To allocate CPU. And technically speaking, every node has a maximum amount of memory in CPU. However, memory can never be exceeded. CPU can. So when you have a runaway workload, which I have seen so many times, when you have a runaway workload, it may be, and now you also can overcommit as well the work. So even if you don't have a runaway workload, but you've overcommitted and you have, your workload's using 500% of the node CPU, quote unquote, capacity, you've got a noisy neighbor, right? You've got a noisy neighbor, and that's going to start taking things down. So you need to consider CPU, like you can actually do something where it like CPU is guaranteed no matter what, because it's reserved CPU. Like you need to consider reserved CPU, which can also cause a noisy neighbor. So that's double-edged. You need to consider how to do pod disruption budgets, how to do pod priority. The level of precision required to do one gargantuan cluster is not for the beginner. It is not for the beginner Kubernetes user. It's not for the beginner consumer of Kubernetes and OpenShift. It is actually phenomenally difficult to do that and not cause a failure. Do not do that. Do not do it.
It's one of the strengths of OpenShift, I think.
It's funny. I do have a customer out where I live that has one huge cluster, and they've been pretty successful with it. But they've learned a lot of lessons along the way. To touch on what Hilliary said, there's a lot of discipline and things that are not intuitive at the beginning that you learn the hard way, right? With one big cluster.
Yeah.
And then there's the it depends, right? Because like I said, you might want to consider reserve CPU, but it also may not be the right thing to do. That may also bite you. That could, it depends. You have to understand every workload going onto that cluster intimately to do that right.
Yeah.
It is a very, very, very delicate balance.
You have to use quota on a big cluster, and then the quota forces people to use requests and limits on their workloads. You're not going to have one big cluster without quota on a per space basis.
I was assuming limit ranges and C groups would be used.
But to Hillary's point, when people are new to, and to your point about kind of the complexity under the hood, when people are new to OpenShift, like a platform team, they don't really understand. I should be using quotas. I should be doing enforcing pod disruption budgets. I should be doing this and that, right? And this is all stuff that this customer and some others that I have had with big clusters learned the hard way over a few years, right?
Yeah, and
with
then
outages along the way.
You have people who would tell you, oh, you don't need to use CPU limits. Definitely use requests, definitely use memory limits, but you don't need CPU limits, right? And they have all these arguments for it, and it's so that you don't end up with throttled, workloads, and they're allowed to exceed and all this other. I'm like, that only works like to a degree.
I like not using CPU limits, but I also recognize that the teams on the cluster have to be very disciplined and understand what that means. That means that when you put in a request, that request has to be enough for your application's SLA, because that's what's guaranteed. You're not going to get any more than that.
And even then, it's not really guaranteed because you can overcommit. It's not really guaranteed because pod priority plays
the CPU request is guaranteed.
It won't schedule, but
it won't
you get into race conditions, right? You get into race conditions. You can get into race conditions.
It won't schedule, but if it's got scheduled, it's guaranteed from my perspective. Now, can you tweak the knob under the hood in OpenShift to kind of make a request mean something else? Yes. Should you? Probably not. or do even worse, my customers who like to tweak the VMs to say, well, pretend you've got 4, but really you have 2 CPUs, right?
Yeah.
Stuff like that.
Yeah.
There's all sorts of games you can play, but to your point, Hilary, that all of this requires a lot of discipline to operate a big cluster successfully. And I've had customers that have done it successfully, so I wouldn't tell somebody never to do it. But I think all the stuff that you said is a very good cautionary tale, right? Like you want to be sure you know what you're doing before you go down that path.
I really, like I said, I don't recommend it.
Yeah.
If you ever plan on doing load and stress testing, don't do it on your production cluster. not unless you are deliberately happy to take down production. Do not do that. And like I said, etcd getting full. It's something that somebody was like, I've never seen that. I'm like, oh, I can't even count the number of times I've seen people like need to like etcd being too full. I've seen it happen because of the number of Tecton jobs people have used. I always joke my first great contribution to open source was going to the Red Hat Tecton team and telling them, hey, you need to go and turn on auto pruning, and then could you please backport it because our customers' clusters are falling over because they don't know to do this, right?
Yeah.
And they did. They immediately understood the problem. They immediately jumped on it. They immediately did it. And I was like, thank you so much, because SRE is dying under the weight of this issue. And so like, bless our Tecton team for that. But then Argo CD did the same thing down the line. The Argo CD team had to go do the same thing. These things do happen. And especially when you are leveraging solutions that you don't write, you may not know what they are not doing in a way that will allow you to avoid those types of situations. Not to say you shouldn't use Tecton and Argo. You absolutely should. But don't just think I'm going to throw together all of these things and I can run everything I could ever want on a gargantuan cluster and nothing bad is going to happen. Because that's not reality. Yeah. Really bad things are going to happen. They are 110% going to happen. I have seen it my entire 4 years as an SRE here at Red Hat, and it literally only took me a few weeks into the job before I saw it the first time.
But there's a balance there. I mean, I wouldn't advocate for one big cluster to rule them all, but neither would I advocate handing out clusters like candy to everybody.
No,
right?
Yeah, I wouldn't do that either.
There's got to be a balance, and typically for me, the balance, and same with Argo CD, in how people access it is really where your trust boundary is, right? Like if you have a trust boundary at an organization, say it's at the directorate level or some other level, that could be a cluster with the different teams in that organization using it versus an enterprise-wide cluster.
Yeah, 100%. There's definitely a balance. Like you don't need, and people should give people strong enough computers to be able to do things nicely in local development. Like, you know what I mean? Like a dev cluster should not be because people can't use a local machine. There should be like a really good reason why you have a dedicated dev cluster. And like my team, we spin them up and spin them down a lot for various reasons. So they're very ephemeral and not like a permanent thing. And then we also have local stuff that we run as well. But you know, staging, production, would recommend those two.
Yeah, I am a fan of a dev cluster because to me that's the first point of integration for everybody's code. Yeah, it becomes a shared environment for integrating your code together for the first time.
And anybody that's worked in DoD or government space at all, like they do not get good laptops. They don't get good hardware. They do not get good development environments.
Fair.
So like,
Fair.
And I grew up in that environment, so like I'm used to like scrapping together as much BS as I possibly could just to have something decent. And yeah, so like a lot of times you'll have to like spin up a virtual machine, you know, if you have OpenStack or, you know, maybe inside AWS or whatever, and then build from there. So I'm a huge fan of like at least a small dev cluster. Like, yeah, if you know me, you know I'm about to say hosted control planes or HyperShift. Yeah, something you can spin up, do your thing, tear it down.
Yeah, and that's the thing is it's up and down. It doesn't have to be this long-lived thing. Like like I said, we spin them up and tear them down multiple times a week in my team. And there may be 1, there may be 2, there may be 0. It really depends on what's going on that week for the team. And then of course my team is developing a managed OpenShift product. So what we're not actually running clusters like the customers do. We do have a long-lived cluster where we do some experimentation and so forth, but that's a whole different thing. The actual process of building OpenShift doesn't look like the process of building on top of OpenShift. Wholly different world.
Yeah, I say I similar background to Johnny. I come from 15 years of shadow IT, where you didn't have it. You couldn't get access to the kits. You had to go and get your own kit. And a lot of the customers I'm dealing with at the moment, they like to have a development cluster, because not only the situation of removing the kind of overhead of the local laptop doing the builds, Podman and those kind of things, but it's the security of the builds themselves and the security of the source code. So if you run something like dev spaces, for example, you can have dev spaces running on the cluster. Dev spaces gives you access, have a hosted version of Bitbucket on there as well. So your code never leaves the cluster. Your builds are never done outside of the cluster. Your images never leave the cluster. So when you're dealing with a highly secure agency, they love having these big development clusters. I've just been involved with rolling one out with the MOD in the UK, which is a huge cluster just for developing software on. But I want to bring the conversation back to something earlier very, very quickly. I've seen a lot. I used to love OpenShift 3, and OpenShift 3 was a Frankenstein monster to administer.
Oh my God, it really was.
It was OpenShift 4 is people who use OpenShift 4 didn't use OpenShift 3 do not know how lucky they are in this world. But the question I've got is actually something about the hosted control plane. So the hosted control planes, the ability to fire up, for example, a control plane as an application on an existing OpenShift. Where does etcd come in there?
Oh my God, it's like 3 etcds in a trench coat.
Yeah.
So okay, keeping in mind that I did not really work on the AWS HCP, but I am involved in it, not like even that involved because I'm not responsible. I'm responsible. I'm just not responsible for its architectural direction. So I'm informed and consulted, but not like responsible for it. Like there's a dedicated Azure Red Hat OpenShift tech lead who has his entire focus is Azure Arrow hosted control planes. Whereas mine is I'm continuing on the classic with my other two team leads. Like the three of us are working on the classic current version of the service, right? And then we're sort of slowly bringing as that matures, because it's not beyond it's barely an MVP status right now. Anyway, the point is it's going to be different. You don't need to care as a customer. You shouldn't actually have to even care as sales under the hood. But essentially, and there's an architecture diagram for it, which I wish I had a whiteboard because I don't. I had a glass one and it shattered. I haven't replaced it. Anyway, wait, I have a notebook. Hang on, here we go. I'm going to, from memory, I'm going to draw this for you. We're going to get into this. Okay, so you actually have your this is like a ROSA cluster, right? And then boop, 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 and this is a kind of a node boundary there, and then it goes to a workers, and this is that, and that goes to there. Yeah, okay, it's a really bad drawing. So you have your host cluster, right, where the hosted control planes live. And essentially, it has its own control plane. This is a classic like ROSA cluster, just like a customer would use. And then you have 3 etcds, or just like as if it were like 3 master nodes. You have 3 etcd replicas, and they're each on different nodes, right? And so it's like a bin packing. This is similar to how we did manage Kafka back when we did manage Kafka. So you've got the 3 etcds, right? And they are each on different nodes. And then there's also on the, I believe this is correct. God, somebody double check me. I went through this a long time ago. On the actual like worker nodes or the data plane part of HCP, there was actually a corresponding set of etcd. So we basically have etcd in a couple different places. So there's the main cluster etcd for the hosted control plane. There's the actual control plane etcds that live across 3 different nodes, and they're technically on worker nodes in terms of that initial cluster topology. They're actually on worker nodes, and then they're like kind of bin packed in alongside, every other HCP's control plane. I don't even know what to call these. Like, it starts getting so weird. It's the control plane within the control plane, and then over here you've got the data plane. But that control plane actually runs on a data plane because there's a separate control plane. Horrible naming.
It gets a bit Inception at this point.
It gets a bit. It is at a little bit of an Inception, right? And so then there's the etcd that is local to the data plane where the customer stuff runs. And so that's what we've done. It's like, as I always say the joke, it's just 3 etcds in a trench coat. We called it hosted control planes. And then there's some privileged networking and some other stuff that happens. And then the real magic actually occurs with the hypershift operator. And that's the thing that knows how to do the stuff. That's really the meat and the guts of the hosted control plane.
Is that the one that used to have the cool name Kubernetes? Because there was a super controller of Kubernetes clusters called Kubernetes, which I think morphed into hypershift.
I actually don't.
Complete random aside, of course.
I don't know. It may have. That is a level of knowledge that I don't know. But yeah, so I always joke that that HCP is actually just 3 etcds in a trench coat. It is far more sophisticated than that. If the hypershift operator is a trench coat, it's a very, very, very nice trench coat. But anyway, that's actually how that roughly works. It will look different in the Azure version, but not so different that it's unrecognizable.
Yeah, so a quick question on the Argo CD side, because you're in the ARO. Because I assume the listeners understand the difference between ROSA and ARO and self-managed and all those kind of things from an OpenShift perspective. One thing I talk about to lots of the customers is Developer Sandbox, which is our free-to-use Developer Sandbox. We've got lots of cool stuff on there. OpenShift Vert, so you can fire up some virtualization now. OpenShift AI, so you can play with your LLMs and things. But we haven't got Argo CD on Developer Sandbox because of the complexities of security. You know, you can do a huge amount with Argo CD. You have to be very careful on the way you control what people can actually do in terms of distribution applications and creation of objects from the objects that are created within Argo CD. Has there been a thought of having a managed version of Argo CD or a managed version of OpenShift GitOps, specifically for the managed platform users or you know, anybody basically that has a target Kubernetes system? Because I've always thought that'd be really useful.
Oh man. Okay. Like this gets into like, I'm just an engineer. This is a business unit question, but okay. There is a long and storied history of managed services on top of managed OpenShift.
Yeah.
The issue, there's a few issues. When we look into adding a managed service on top of managed OpenShift, what we've done and it still exists. We've done in the past is there's a dedicated like team that just handles that layer. It is typically speaking, the way we do managed services in terms of like what S3 provides here is that we try to not ever investigate the customer workloads. Like if a customer workload is at issue and it is causing, pressure on the API server for some reason, we will typically identify that. But then from there, we kind of hand off to the customer because we don't know what's in their thing, right? We don't know what's in there. And there could be unencrypted social security numbers for all we know. Like we have to run under the assumption that we would stumble upon PII and we need to avoid that at all costs, right? Because it's really... it's a security and privacy thing that we don't know, we don't look, we don't see. And even within our own systems, we've actually built in things like we can't, especially on the Arrow side, like there's things that I cannot do without going through this major break glass situation. If I'm doing that, it is to save your cluster from death, right? That is the only reason I am doing that. Otherwise, I don't touch, I can't see. So when you have a managed service like that, it's much harder for that important degree of separation to exist. It can, but it is harder because if you want to SLA Argo CD's behavior, then when it doesn't do the thing or it doesn't do the thing in the time it needs to do it, that means getting deep into it. So there's a bunch of like compliance issues around that. Then there starts to be so how do we actually manage it as in terms of like, what are we able to do in terms of managing it that doesn't step on a customer's like capabilities? So keeping in mind that when you start adding in like operators, and so forth. Like they tend to be like cluster scoped. So sometimes you can't have multiple versions of the same thing. Like you can have multiple Prometheus, right? But you can't have multiple OPA. So for us to be a managed service, one of the things that we need to do is have opinions and enforce our opinions. And so one of the ways of successfully enforcing opinions would be to run a policy agent like OPA or Kyverno, right? But then if we do that, customers can't. So how do we successfully manage and support a service without stepping on a customer's capability of using their cluster? That gets very tricky. We've had to do some of the things that we have done to do this are, you wouldn't believe them. We're not even going to get in there, right? We've had to do a lot of work. So the historic on the managed services, that made it very difficult. So there's a lot of operators, and then you had operators within operators within operators. So you had custom operators wrapped around, for example, 3-scale. Custom operators wrapped around 3-scale to like how to create a managed 3-scale. But then you end up seeing things like the managed version of 3-scale, which was called Rome. And before it was Rome, it was called RHMI. And RHMI had a bunch of other stuff. And that ran also that goes all the way back to managed services on OpenShift 3. So OpenShift 3, then OpenShift 4. Now it's called Rome. There was like things that were done and made better about it. But there were some capabilities that actually were suppressed in the managed service version compared to the normal self-managed version. And there was reasoning for it was the technical difficulties of guaranteeing the promises while allowing those capabilities, which were a little bit more, like, if I would say, dangerous. So like this starts getting into like the engineering difficulties of having a managed service and what that means, and the fact that a managed service must inherently be opinionated and enforce its opinions. And also, does that actually then allow us to meet the customers where they are? Yeah. That's really challenging. And we still even see that in the managed OpenShift space. Like that's really why hosted control planes is such a nice thing for everybody. One, it keeps the cost down, but two, it allows us to do the management in terms of like SRE and our opinions without actually trampling on customers' desires for customization. That balance, striking that balance is actually been the thing that I think our customers help us so much to understand what that needs to look like. And so really trying to that's why that's why we developed HCP on AWS. That's why we're doing it in Azure, is so that we can do that. We can manage something, we can promise something, we can keep something, stable and going the way a customer needs it without impugning on their ability to leverage the full capabilities of a customizable platform the way a Kubernetes-based, especially OpenShift platform actually is. And then you start getting into especially some OpenShift has some cool features, like the way we do machine pools and all that other stuff, right? That is really not there in Kubernetes. There's been a few things where I've been doing something on my local kind cluster. I'm like, oh, what about this? I'm like, darn it, that's an OpenShift opinion. Right? It happens. Yeah. And so, but some of times, when you need to be opinionated about how people do things so that you can guarantee their experience, in other ways, you damage the experience. And so I will say that's the challenge with building a managed service. It's not in something that can't be reconciled. It is something that's just very difficult, requires a lot of market research, really needs to have legs under it to be worth the effort. That's a little bit of an armchair business opinion because I'm an engineer. What do I know? And so there's engineering difficulties, there's business case difficulties, both of those things working together. I don't know. We do things like this. We get customers engaged in things like this. We help them to be successful in ways like this. I think that is, and by this I mean this stream. I think that is a little bit of an easier way to help people understand. I don't know. Welcome to my TED Talk on managed services.
The other thing from my perspective as somebody that was in sales as a solution architect is that when we had the managed services, the first question we get from customers is, how do I run this on my local cluster? Right? So you have to satisfy both use cases with the same piece of software. And a lot of times the managed services were never designed to be run by customers, right? So the one nice thing with Argo that I'll say in terms of your question is that upstream in Argo CD community, what they call Argo Project Labs, is that there is work happening around an agent architecture that is designed to kind of make Argo work better from a service perspective, in the sense that you can essentially run the UI, the server component, potentially some other components on a central hub, and have the application controller and other components distributed to clusters, right? And then have more of a SaaS offering type of thing based around that. And then customers can build and manage that themselves. And that's still quite a ways off, but just as an FYI, in terms of things that are going in that direction. And that's the direction I prefer. Like if we do a managed service, I'd like to see it packaged as a way the customer can run it as well, right, on their local cluster, not just Red Hat running it.
I think this is, oh my God, this is such a great question. Isn't that why people are using open source? Is it's not opinionated? Yeah. Welcome to the entire reason we built hosted control planes. I don't know what else to say. I really don't know what else to say. It's, if you look at it from my perspective as an SRE, right, I'm responsible for keeping somebody's cluster healthy, regardless of what they do to it, right? That's impossible. So there has to be some boundaries. But so we built close control planes to really solve that problem, because if the control plane is somewhere where the customer can't, change it, then they can do whatever they want to their data plane. And as long as it can talk to the control plane, everything's copacetic. Now, if they somehow break that connection, I can't help them, right? Like if you do something to your networking so bad that you've managed to lose the connectivity between your hosted, like your HCP cluster data plane and where we have the control plane, please undo that networking change. But realistically, that's not really a situation that occurs. People typically know what they're getting into when they're going for this.
Yeah, I'm a huge fan of HyperShift. I love it. I think it's awesome. And then after we had Eric Fried on, Hillary, I went and started messing with Hive. And Hive is also super dope. Like and the combination of both of them to spin up like a traditional, control plane and compute cluster, and then, also having the ability to spin up like a hosted control plane type cluster, all from pretty much the same place using very similar code. It's super dope. And then especially when for me on a development, from a development side, I'm spinning clusters up all the time and tearing them down. But then when you're trying to help, I was trying to help a customer in a workshop, right? And it's okay, well, hey, we could do something like a Hive or a hosted control plane or something like that. And you can spin up now dozens, scores of clusters in a single command. And it doesn't take days or whatever, hours, whatever it takes. Especially with HyperShift, it takes probably 30 minutes, 45 minutes. It's so, oh my God, it's awesome.
Yeah. Oh yeah. The speed too. This provisioning speed on HyperShift HCP. So much better. So much better. We are actually over time, and we never really got deep in. We didn't actually, I think, ever talk about what we meant to talk about.
I know. I joked with Uth that maybe we should come back on again to actually talk about what we were supposed to talk about.
I think we're gonna have to. Yeah, I think we're gonna have to actually, because I love our developer hub and our all of the things that we actually have in there. There's a conference that they do in the Bay Area that I've been to a few times. And that's it's like Developer Week, and it's that we show the developer hub and all of our resources and all of the free ebooks you can get there. And so we're we legitimately need to have you guys back on and actually go into that aspect. That said, this ended up being a great conversation anyway. And we can fight about multiple clusters versus one cluster. And man, if you have a big one cluster, then the whole thing goes down. Congratulations, your blast radius is all of the things. I don't recommend for it. There's reasons I don't recommend for it.
That's why I use Red Hat OpenShift Disaster Recovery.
That's why I use Red Hat OpenShift Disaster. That's not a thing it really ought to be. That's not a thing it really ought to be. That is a validated pattern we could make. Disaster recovery. There we go. Where's Marty? Jonny?
Yes. I think we're working on I think somebody's working on one. So it's in the works for sure.
Fantastic. All right, we're 5 minutes over. I think that really means it's time to end the stream. Otherwise, I won't get food today.
I just want to answer this question really quick from Darth Vikes. So Darth Vikes, the difference between HyperShift and OpenShift is there's really not, right? They're both OpenShift. So HyperShift is just the means in which it's deployed. So OpenShift, when you think it's just Kubernetes, it's enterprise Kubernetes. HyperShift is a hosted control plane. So it's just a deployment tool to help speed up the process. So instead of having a node or 3 nodes or 3 control planes and 3 computes or whatever it is, the control plane's hosted on a cluster, and then the compute plane or the data plane rather is separate. And it's literally like if you've ever used EKS or AKS or StarKS, whatever, it's presented to the customer the same way. So like when you do an OC-get nodes, you see only the worker nodes, not the control plane or anything like that, because it's all on a hosted cluster outside of the scope of the workers. So they're both the same. They're both OpenShift. They both run operators. They both do things. You can deploy apps just the same. But it's just the way in which the cluster is provisioned.
Yeah, cluster topology is a little different. And it's it is I guess you can use build from source and make your own hypershift clusters if you wanted to. I don't know, never tried it. But no, it's not like Cappy. Let me just go get the okay. Come back in a few weeks. I will schedule an overview of HCP for the viewers and the audience to explain what hosted control planes is. I did explain it a little bit earlier. It's 3 etcds in a trench coat. And the trench coat is the hypershift operator.
That sounds so wrong.
I'm gonna put that on a t-shirt. Yeah, it's how much time do I have? I have time. I'll stay on. Okay. So if you guys can drop if you need to drop. I think Jonny, you have a meeting. Coming
up.
Right. So so cluster API is a way of interfacing with the cluster, right? And so you could actually have cluster API and HCP, right? Because you have to, in order to interface with the cluster, like you have to like run an instance of Cappy. In that way, it's somewhat similar to what we described earlier, which is Hive, which is sort of like software that runs on a cluster that does like control, like does day 2 stuff on the cluster. So we use something called a sync set, and the sync set can like ensure that if this cluster has this label, then Hive knows about the cluster, knows about that label, drops down the sync set, and the sync set will do something like install a custom workload or apply a custom CRD, like apply a CRD or some things. I mean, it can be pretty much any arbitrary YAML. You can literally have it define a cron job, and then there's going to be a cron job that runs for whatever reason, right? So, and so the Cappy doesn't allow for like fully arbitrary YAML, but it's kind of the same thing in that you have a service that runs, it knows about your Kubernetes cluster, and then it can kind of interface on like a little bit of a privileged, I guess, way to do things to the cluster, like to do some sort of controlling action against the cluster, right? So that's really what Cappy is. So you could have that and a hosted control plane cluster, because the hosted control plane is more about cluster topology. So kind of like what Jonny said earlier, if I'm a customer of Red Hat and I say I want an HCP cluster, and I go and I do OCM create cluster. I don't actually remember the command line for it because I am on the Azure side and I know the Azure command line for it. Anyway, so the but yeah, if I go through OCM and I go use, you can use a GUI, right? Just use the GUI, right? Go create an HCP cluster. What it does then is the control plane actually gets created on the hosting cluster, right? They call it a hosted control plane because your control plane for the cluster that you are creating is hosted somewhere else. We host it. And so you actually don't really, it doesn't go into your Amazon account. So you're not paying for like the CPU usage and like stuff that it does, right? So we host the control plane. It basically exists across, I reduced it down to 3 etcds. It's actually, there's more to it than that. Please understand that it is more complex than that. But but your control plane basically is spread across 3 nodes on the cluster that is like the hosting cluster. And then you get 3 worker nodes, or however many you specify, but like it's going to be typically a minimum of 3. You're going to get your worker nodes, and those are going to be bootstrapped into your Amazon account, and it's going to be really just kind of similar from there to if you were running a traditional like OpenShift on AWS or ROSA cluster. It's actually going to be more of the ROSA cluster side because if there's any, I don't think we run anything on the worker nodes that is ours, but typically speaking, like our management is done in the style of what we did with ROSA for the managed OpenShift offering. And then of course, like SRE still does things like make sure the control plane is alive and healthy and all those other things like we do for any ROSA cluster. But so from your perspective, this also kind of divorces the some of the needs for us to enforce our opinions that in the way that we currently have to do. And so it allows you to like leverage more of the OpenShift features better than kind of in the more traditional managed service offerings where those leveraging of those features could step on some of what the SRE workloads do and enforce so that like, you know, we would be able to guarantee cluster stability. So you kind of get the best of both worlds by us separating out the control plane, which is the thing that we're really responsible for taking care of from your data plane, in that now you can do more things. Like I said earlier, as long as you don't do something that completely breaks the ability of the control plane to interact with the data plane, you're more or less good to go. And I don't quote me on that because I don't support the AWS side of hosted control planes. And maybe one of my SRE compatriots is going to come up to me and be like, Hilliary, what did you just say? Please read the docs and do what they say. But that hopefully kind of clears it up. What HCP is and how it's different from CAPI or different from kind of traditional ROSA. It's called ROSA HCP, which is Red Hat OpenShift Service on AWS. I'm bad at acronyms, but yeah, that's the thing. That's how it works. Does that, Jonny, keep me honest, does that sound like a good explanation?
Yeah, I think so.
Cool.
Just curious, Hilliary, the hosted control plane control planes, it's like it is turtles all the way down. Are they running on the managed services control plane or are they running on worker infra nodes so the customer is still paying for them indirectly?
The second one.
The second one. So the customer is still paying for it indirectly.
So, God, it gets kind of like, so we own the cluster, right? We own the cluster where the control planes are all hosted, right? And so I don't know how the money exactly works.
Gotcha. So they're in a separate cluster, cluster,
they're in
not the customers. Gotcha.
Yeah.
Okay, that
but
makes
it's not
sense.
like, I mean, so it's like there's parts of it like, but you pay a licensing fee, so you are paying, like you're not getting it for free.
Right.
But the costs are reduced because the bin packing model that we do for those hosted control planes allows the costs to be much lower.
Right. But that's an implementation detail. From the customer's perspective, they just got an OpenShift cluster with a control plane somewhere else.
Yes.
They don't care whether we're running it in VMs or we're running it as, pods on another OpenShift cluster that we manage, right?
Exactly.
Yeah. I was thinking more of the scenario where the customer wants to set up their own HCP environment and manage it themselves on a managed OpenShift.
You could, if you wanted to, you could do that. But like, then like, so if I like, you could mirror the way we do it, right? You could set up, you set up a ROSA cluster and then decide to install the Hypershift operator. And then you can go create, like, I don't know how you would, like, there's going to be some particulars in there that are going to be
I was just thinking of those ephemeral use cases we were talking about earlier, but I mean, you could also just go to the Arrow provisioning automation and set up your own brand new Arrow cluster as well. Right. And not have to pay for those control planes. You get the same benefit at the end of the day.
Yeah, exactly.
Yeah.
So,
okay, thank you.
If I were telling a customer what to do and you need to like have readily like ephemeral things pretty fast and you want it to be the managed service, like just, use hosted control planes is good. It does the things.
Yeah.
10 of 10 recommend.
Cool.
Yeah, and Tal is in the comments. God, I love you, Tal. Thank you so much. Like I see, helping answer all the questions. But yeah, okay, great conversation. Let's have y'all back to actually talk about the Developer Hub sometime soon, and then pipelines and all of the things we were supposed to talk about today. We'll just schedule that in sometime. I think I promised the audience we would do after October, after the first stream in October, we would do a general observability episode because that has been requested. So I will do as requested. We'll bring you back after that sometime, and then I will bring in somebody to explain hosted control planes, I guess sometime in November. Looks like the rest of my year is planned. Awesome. Thank you, audience. Gerald, thank you for your time.
Thank you.
Sorry that
it was fun.
Sorry we didn't get all the way there, but I think this was a great episode anyway.
Yeah, it was lots of fun.
Thank you, Jonny, for staying late. I'm going to make you do the outro in a couple seconds, but first I'm just going to remind everybody that we'll see you in 2 weeks to talk about it's like an assisted AI for OpenShift.
Oh.
Yeah. We're going to have my friend Nunn come back from Robusta. He's got a cool little demo to show. That'll be really fun. People love AI these days, I'm told. Then 2 weeks after that, we'll probably do reverse it. Sorry, in 2 weeks it's OC Mirror. I take that back. In 2 weeks it's OC Mirror, which builds on our disaster recovery thing we were talking about earlier. 2 weeks after that, it's assisted AI. I don't remember dates anymore. Somebody save me. I need more coffee, clearly, or slothy, however my mug says it. Coke is also a good idea. Excellent choice in soda. Until the next time we see you, whatever our topic is, choose your technical debt wisely, and it will be 2 weeks from now. Goodbye.